Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's video, we are going to discuss the average atomic mass. Now, average atomic mass, the word average over there, it is basically showing that we have to take the average of atomic masses. So, by definition, average atomic mass is mainly the measurement of the average weight or the average mass of the atoms that are going to make up the element. So here, if we have any element like we have the oxygen or we have the hydrogen element. Now, what type of atoms are going to make up these elements? So, the atoms that are going to make up these elements. Likewise, if we have the isotopes of oxygen and we have the isotopes of hydrogen, as isotopes of hydrogen are three. So, how we can measure the average atomic mass? So, we have to take the summation of the atomic masses of all the atoms, and at the end, we will have the average for this. This is known as the average atomic mass. Basically, the weight average mass of an element is taken from the isotopes. How we can take from the isotopes? For this purpose, we need the relative abundance of the isotopes. Relative abundance of the isotopes. When we take the relative abundance of the isotopes, and it is basically based on 1/12 of the mass of carbon 12. So the 1/12 or mass of the carbon 12 is also known as relative atomic mass. It is also known as the relative atomic mass, and that relative atomic mass is measured in the unit atomic mass unit or AMU in simple. So here we have another example. We have carbon 12, its number one isotope, and we have carbon 13, its second isotope. So the first one is having its relative abundance 48%, and the second one is having its the relative abundance 52%. So by solving the problem, we just gain its atomic weight, that is its average atomic mass. It is 12.52. So this is basically the average atomic mass of the carbon. Next, we have another definition for the average atomic mass. So, the weighted average mass of the natural sample. Any natural sample means any pure element of an element is calculated by multiplying the natural abundance of each element. So, in simple words, we have to multiply the natural abundance or the relative abundance of the element with its exact mass number, and that mass number, it must be in AMU, that is atomic mass unit or the relative atomic mass, and then summing up means we have to just take their summation or we have to add them. So the average atomic mass, if an element is having 2 to 3 isotopes, then the mass of one isotope multiplied by its relative abundance and the mass of the second with relative abundance and plus third one and its relative abundance, and so on if we have more number of isotopes like that. So here we have the three isotopes of neon. The number one is neon 20, 21, and neon 22. These are its atomic mass unit, that is average atomic mass unit. It is AMU or the atomic masses, and the third one row is having its natural abundance, that is in percentage. First one is 90%, second one is 0.26, and third one is 9.2%. So from this we can be able to find its average atomic mass of the neon. For this purpose we have to solve the problem. Here we have a sample of neon that is consisting of neon 23, 21, and neon 22. So we have the three isotopes of neon, neon 20, neon 21, and we have neon 23. So here we have three isotopes of neon. In the percentages of 90.92, 0.26 and 8.82, they are present respectively. We have to calculate the fractional atomic mass of the neon. The fractional atomic mass, or we can also call it as the average atomic mass. So here the question we have simple from the relative abundance of the isotopes we have to find the average atomic mass. So the formula for this we have average atomic mass, it is equal to atomic mass of neon 20. So here we have neon 20, multiply it with its relative abundance, plus we have neon 21, multiply it with its relative abundance, and plus we have neon 22, multiply it with its relative abundance, and we have to divide it with the 100. So by putting up the values, neon 20, its mass number is 20, multiply with its relative abundance, that is 90.92. So plus we have neon 21, multiply with its relative abundance, that is 0.26, and plus neon 22, multiply with its relative abundance, that is 8.82%, and divided it with the 100. So we get its average atomic mass of neon is 20.18. So to find the average atomic mass of any element, we need to know its relative abundance and its mass number in AMU. So this is a simple way to find the average atomic mass. I hope you guys understand, and you need to do the practice for the average atomic mass at home by having the different examples as isotopes of hydrogen, we have isotopes of chlorine as well. And in the next video, we will discuss about the analysis of the compound, that how we can analyze a compound. For that time, have a good day and Allah Hafiz.